This is Mrs. Sebastian, and we're going to look at describing functions, and this is Tennessee State Standard 8FB5. Martin moved to a new house. He tracked his electricity consumption over a period of 12 months. Consider the graph below, which shows the relationship between his monthly monthly electrical consumption and the time. So when he moves in, he has been at this house for 0 months. That's when he moved in. That's what this shows us right here. Okay. Then his electricity usage went up until that's 5 months here, until it kind of plateaued, and then it went up again. Okay, so let's see what statements these show. So Martin's electricity consumption increased for some time and then decreased for some time. Well, I never saw it go down. Decreased means down, and his graph never went down. So I'm going to say that's not it. Okay, Martin's electricity consumption kept increasing continuously throughout the period. Well, there was this period right here in the middle that kind of flatlined. It stayed the same. So that means it wasn't increasing during that. Martin's electricity consumption remained constant for a period, which means for a short time, his electricity consumption remained constant, which means remained the same. So that one sounds pretty good. Martin's electricity consumption kept increasing at the same rate throughout the period. Well, that's not true because our rate of constant change, okay, that constant did not change at the same rate as it did when it was increasing. So D cannot be it. So I would say C is your answer. Ryan went on an 8-hour hike. Consider the graph below, which represents the relationship between the distance traveled by Ryan and the time elapsed. So which statement best interprets information provided by the graph? Okay, so let's see what happened. As he started, he had gone 0 miles in 0 time, and it goes up. It changes a little bit and goes at a little different slope. Then it goes constant. Then it goes up, a little slower, and then up again. Okay, so Ryan's distance traveled increased both before taking a break and after taking a break. So I would say, okay, here's where he took a break. That's how far away he was. That sounds about right. So it increased and then it increased again. Did he travel at a constant rate? No, he did not. He changed the entire time. He took 2 breaks during the trek. Well, we've only got that one time when he didn't go any farther and his time remained the same. Ryan's distance traveled increased at a nonlinear rate for the entire time. Well, that's not true because it did go up at a constant rate, then it went up at a constant rate, and so on. So I would say A. Okay, which of the following graphs increases at first until it reaches its maximum, then decreases thereafter? So we always look at a graph from left to right. Okay, so when I look at my first graph up here, W, okay, I want it to increase at first. That'd be going up and then down. So this one can't be it. This one goes down and then up. So it decreases first and then increases. So that one can't be it. Z just increases. So that can't be it. And let's see why it does go up and then it goes down. So it increases and then it decreases. So Y would be your answer. The gasoline consumption of a town was recorded for a period of 10 years. So the graph below shows the amount of gas consumption in time and years. So if you look at this graph, you do see a curve here. And I would say that's a nonlinear portion. And then the rest does go up in straight lines. Straight. None of it is ever constant and it never declines. So I would say that it increased at a constant rate. Ooh, that sounds good. Uh-oh, entire period. Well, not for the entire period. Gasoline consumption increased at a constant rate for several years. That one is true. Let's keep going. Increased for some time and then decreased for some time. Well, our graph never went down, so it can't be C. And then did it ever remain constant for some time? No, our line never went straight across, so it was not constant. Holly was conducting a science experiment to determine the rate of cell division. The cells that she was studying divided at a nonlinear rate. Which of the following graphs could represent her results? So I see that Z is a linear graph, and I see that Y is nonlinear because it is not in a straight line. So I would say graph Y. The graph of the function is shown on the coordinate plane. So initially the function is increasing because the x values are, okay, let's see. So it's going up. This is when it increases. The x values are increasing. And the y values are going from down here, going up. So they are increasing. Okay, the function is decreasing when it's going down. Well, let's see. I'm just going to pick this point right here to kind of show you what it is, and here. So that'll be 4, 1. Okay, so if you look at the x values are increasing. 1 to 4 does increase 3, so I'm just going to put increasing. But the y values go from 7 to 1. So 7 to 1 would be going down. It's decreasing. Okay, describe the behavior of the graph below. So as the input increases, that's your x value. So as the x's go to the right, the output increases. So is the graph going up? No, it's not. Okay, so as the input increases, the output decreases. So your y's are going down. When you have opposite, one increases, one decreases, that means it's a negative slope. And our graph does have a negative slope, so I would say C, but let's look at B and D. So as the input increases, the output decreases at first until it reaches 0. After that, it increases as the input increases. That means it does two different things. Our graph is a straight line, so it's not going to do two different things. Same here, the input increases and the output increases at first until it reaches 0. After that, the output decreases as the input increases. So this one would look like this. The one up here would look like that. And our graph does not match either of those descriptions. John shot a toy rocket in the air. Consider the graph below, which shows the relationship between the height off the ground from ground level and the time elapsed. So which best interprets the information provided by the graph? So the height of the rocket decreases for some time and then increases for some time. Well, when he shot the rocket off, it started at 4 feet high and it went all the way up. So it's increasing, so it can't be decreasing. Did the height of the rocket remain constant? Well, I never see a straight across line, so I'm going to say no, it didn't. The height of the rocket increases for some time and then decreases. Yes, it does. It goes up in the air till it gets 26 feet off the ground and kind of curves down and comes back down and hits the ground. Okay, so it increases and then it decreases. So that one does sound right. And it changes at a constant rate for the entire time. That would mean that this graph is a straight line, and it is not. Okay, so which situation best represents the function in the graph? So this is a decreasing graph. So I'm going to see which of these four situations shows us a decreasing graph. So the demand for a car as the price increases. So as the price increases, so as we're going left to right, the more people want it as the price is going up. So think about how many people would want a car if it was $10. How many people would want a car if it's $5,000? The demand is going down. Okay. The temperature of a thermometer throughout a warm day. Well, it's going to get warmer as the day goes on. The amount of water in a bottle as it's filled. So at 0 hours, the bottle's not filled at all, and it's just going to go up. The height of a ball in the seconds after it leaves the pitcher's hands. So it's going to go straight across until it gets to the person. So I would say this one is A. Which of the following graphs is increasing for all values of X? So increasing, so I'm going to look at W first. It's going to go down and then it's going to go up. So that one's not increasing the whole time. This one is increasing all the way. So I'm going to say X is our answer, but let's look at the other two. This one is going up and then it goes down. So that can't be it. And then Z is going down as we read from left to right. So that is a decreasing graph. So I would say A is your answer.